It's Monday, March 3rd. I'm Scott.
I'm Rim.
And this is Geeknights. Tonight, what is programming? Let's do this. I got an announcement to make.
Oh?
An announcement. I'm going to say something that I've been waiting perhaps, I don't know if it's exactly 6 months, but around 6-ish months to say. I haven't said this in 6-ish months, but I'm going to say it now.
You know what? I'll bet an amount of money that I can preempt what you're about to say.
Oh, well, shall we say it on perhaps the count of 3?
1, 2, 3.
Warm today.
Man,
warm yesterday.
Even warmer today. I think woman is retired until about January.
January? I think it's retired till like October.
I don't know. This year and last year, it didn't really get cold until January.
Yeah. One thing I realized, though, I have to go and get rid of these snow tires now and buy regular tires.
Yes, you do.
Yep.
Well, I got to get my 7 months behind car inspected.
Well, do you want it?
And I got to buy new tires, and I got to get the headlights fixed and the horn fixed.
Well, do you want to go to the tire this weekend?
Maybe, but Saturday we're probably going to go see a show, so.
We can go see a show and then go to the tire on Sunday.
Yeah, but I got to go to a regular mechanic, and most mechanics don't seem to be
No,
open
the tire
on
guy
Sunday.
actually does all that kind of stuff.
No, that tire guy you know how much he charges for non-trivial mechanic-y stuff?
Well, you could do your inspection.
No, we can't, because it won't pass the inspection until I get a mechanic to fix the things.
Oh, well, that's a separate problem.
It's a busted old car.
I can't help you with that.
Yeah, I got to go to a real mechanic.
All right.
As in a shady mechanic. That's how I got the car fixed before. I drove into Shady Mechanic in Yonkers and said, all right, dude.
Well, because think about Shady Mechanic in Shady Neighborhood. He deals with far worse cars than yours.
Yeah.
He deals with those cars that are like dragging mufflers on the ground.
I remember I drove in. I'm like, all right, that headlight doesn't work and I don't know why. Can you fix it for cheap? And he's like, well, do you want it to work or do you want it to work well? And I was like, I want it to pass an inspection. To which he said, a real inspection or, And I said, a real inspection. He said, oh, all right, $100. I was like, what? Okay. And then $100 later, he fixed everything. I don't know what he did, but he replaced the whole assembly from some other Sunfire that...
Duct tape and oily rags.
He had some other Sunfire that someone had smashed, so he just took the whole headlight assembly out of it.
Probably. I guess that's pretty easy if you're a mechanic guy.
Yeah.
All right, so yeah, no, not much else besides that.
No, weekend was nice and relaxing. I played some Half-Life 2 since I was booted into Windows. I also played with my laptop a lot.
What sucked today is that in the morning I had like a sweater and a coat, and then on the way home I was like, shit, I'm going to carry this shit. Oh, but that's the end. The sweaters are going in the closet, and they're probably not coming out again.
See, that's the one benefit of the never wear long sleeves ever unless I'm going to a formal ball.
Except for it'll get cold because...
And you know what? It's not cold in the office, and when I'm outside of the office or outside of my house, I'm wearing a coat.
Yeah, but coat's sometimes not enough to be fully warm.
Then you don't have a good coat.
My coat is excellent.
All right, so what do you got in the news? Since I don't
really have news so much, and it's not really a geek bite because I don't really have the product to review it. I sort of want to do like a general informative thing about a category of product that you may or may not know exists. Yeah, I've been looking into these recently for many reasons. And also, some other my coworkers are also looking into them for various other reasons. And basically, when you buy a desktop computer on Newegg, right, the motherboard you get is ATX form factor, most likely, and that's a set of specifications about where the screw holes are, how big the motherboard is, where the things on the motherboard are located, what kind of power supply connector, et cetera, right? Well, there are other choices besides ATX, such as ITX, and also Nano ITX.
Don't forget AT.
AT, yeah, the old one.
No,
and also Pico ITX. Now,
I remember a long time ago, I used to make jokes about how, we should make Pico ITX.
And they have Pico ITX.
Yeah.
It's a real thing. Basically, what these are is they're motherboards. They're full computers. They have a CPU, a sound card, a video card, storage, I/O connections, a battery, a network card, usually pretty much everything, or at least some sort of stripped down limited feature version of what a normal desktop computer has, but very, very small. So you can go out and you can buy for usually under $400 a computer that is wicked small, like wicked small. We're talking like a few inches by a few inches, right? Uses very little electricity, makes no noise because it has no fans. It usually uses flash, but you can use like compact flash or even a little laptop hard drive if you want, but that'll make noise and heat and whatever. And is usually powerful enough to do a whole bunch of computing tasks. I mean, you can't play games on it, obviously. Well, I guess you could play Minesweeper on it, but
you could play Doom 2. It's all you need.
You could probably play Doom 2 on it, yeah.
God, I can play Doom 2 on a 486 with 4 megs of RAM.
Yeah, you usually won't use this as a desktop computer. What you'll use this for is, say, you want to have a monitor hanging on the wall somewhere in your office that's showing like graphs of real-time data. Or you want to have a kiosk in the mall that people will come up to and there'll be some software on it running that they can interact with. Or you want to have a server in your house that runs DHCP, DNS, maybe a little web server, maybe a little SSH, maybe a firewall, something like that. Stuff that isn't too, processor or performance intensive.
Yeah, you're not running the RAID 5 SAN off of this thing.
No. We're just talking about, just software that will run on pretty much any computer of any performance. You can run it on a really tiny, quiet, relatively cheap computer that you can just sort of hide away and doesn't use much electricity. No reason to. I mean, you could scrap together parts and build like a $50 computer, that's just, but it'll be some old ass giant desktop making lots of noise, heat, and using a lot of electricity. So I just want to make people aware that these products exist. That these used to be really expensive, and there used to be not a lot of choice, and most of them were for, industrial purposes, like use it in a factory, and it's in some case that's like wicked, durable and invincible, so if the factory explodes, it'll be okay, or if acid gets on it, it'll be okay. But now there's, more, consumer type ones, and you can customize them for all sorts of uses, and these will be useful for many people. You can do Linux, Windows, pretty much any OS except, I guess, Mac OS. That's not going to work. But, yeah, be aware of these. They may be good for you.
So in actual news, there was a bunch of tech news last week, and I had to actually pick and choose. There's a lot here. There's also a lot of meat space news going on with the, let's say, the fun with our friend Hugo Chavez down south.
Save your meat space news for Thursday.
Always a riot, that guy. Anyway, we'll talk about that later, because I actually got a lot to say about this. And hopefully, by Thursday, we'll know if this leads to war in South America or not.
Great. Sarcastically great.
Yeah. Nothing bad could ever happen with South American war. Luckily, there's no chance of a CIA intervention or anything, is there? It's not like we've ever done that before.
Nah. CIA in South America intervening in some sort of military operation?
Possibly involving some sort of industrial complex?
I never heard of such a thing.
But this news might seem a little off the wall, but I think it's warranted because we talk a lot about technology, and I think we even did a show about how there are a lot of problems in the world that if you applied a little bit of common sense and a little bit of properly put together technology, these problems could be alleviated trivially. There is a kind of annoying problem in the world, and I've run into this a lot. I'm sure a lot of you fly have, that it takes for fucking ever to get people onto a plane in an airport. And they line people up, but people don't line up. And they call people up in certain orders and all this business. And there have been a lot of studies about the fastest way to load a plane.
I think the number one problem, right, is that people get on the plane and they get to their seat and they don't step out of the aisle quick enough. They'll stay in the aisle, try to get their stuff in the overhead bins, which they're not good at all, right? They have no skill at loading the overhead bins. And then everyone basically who needs to get past them stands in the aisle behind them, not moving, and it takes forever.
Now, wouldn't an obvious way to get around this be to load the plane from the back to the front so there's no way anyone could be blocking anyone else?
They do this.
Most airports don't.
See, when I get on a JetBlue plane, right?
Yes, JetBlue.
They'll say, everyone is sitting in rows like 20 through 25, please come up, right? And the problem is, of course, someone in row 20 gets on before the 25 people, right? And is really slow at putting their luggage up. Or the person with the window seat gets on before the person with the aisle seat. I mean, vice versa. So the aisle person keeps the window person out, and then people have to get out and then back into their seats.
Well, I'll put it this way. 2 studies, at least, have shown that the average way that the average airline in the U.S. loads planes is close to the worst possible way you could do it in terms of efficiency.
Alrighty.
And that the best way to do
I have flown maybe twice in my life on non-JetBlue, so I don't know much about any other airline.
I've only actually flown JetBlue once. And if you're going somewhere JetBlue goes and you're not a business traveler who wants some nice, like, first class whatever, it's pretty nice. And a lot of the problems of other airlines go away.
The only other airline I've ever heard that is very nice is the Virgin Airlines.
And from what I've gathered,
if I was going to the UK, I'd probably take them.
From what I've gathered, almost every airline that flies around Europe is awesome compared to most U.S. airlines.
Yeah, like I always see like ads for Lufthansa, and it looks so nice.
Of course, that's like first class.
I saw a YouTube video of the inside of first class of an airplane going to Dubai. Oh man.
Yes, if
they had more gadgets built into that first class seat than we have in this whole house.
You know what I could imagine? I wouldn't be surprised if I were Dubai, I would simply state that you can't have coach and still fly into our airport because obviously those people can't afford to be here.
Pretty much. Next up, Monaco.
Yeah. But no, the deal here is that they've pretty much determined that if you just force everyone to line up in order by row ahead of time before the plane is ready to be loaded, or at least half the people load up, like make them stand in line in order. If you're not in the right place, you have to wait till everyone else is on board. Punish them in that way. And then just load people row by row, seat by seat, strict order. No one gets any say. No one gets any sort of special treatment.
Well, that's another thing is that even on JetBlue, what they do, and I think it's an FAA regulation, is they say anyone who needs help getting on the plane, get on first, right? And they take care of you. Like if you're an old person who can't walk, or if you have a wheelchair, or if you have a baby or something. And really, when you think about it, it would be more optimal to have those people on last than to put them on first. But
actually, I read an article that said just as much. Yeah, because there's no one else in the way, no one moving.
Yeah, pretty much those people, right? It's tough to get them on. It takes some time. So what you do is instead of putting them on first, forcing everyone else who can get on quickly to wait, you let everyone get on real quick, then you get the slow people on, and then you go. And there's no delaying the quick people. There's no chance of the slow people holding up the quick people.
Now, sadly, while this article is all like, and all these articles, yeah, you could really super efficientize. I like that. I'm going to say that word more often. Efficientize.
There really isn't another word for that. I needed to say efficientize.
Optimize.
Okay, no. But,
optimize is close.
Well, you have to say optimize the efficiency. It's like a two words.
Saying optimize the efficiency just reeks of utilizing the buzzword.
Redundancy, yes.
To maximize the, okay.
Yes. So we need efficientize, I think, has to be a word.
Now, this article, like, we could do this, but the studies do overlook one important thing.
Human psychologies?
The fact that when you fly, and I've seen this every time I've ever flown, it seems that the majority of the people getting on the plane are families who have probably never flown before, or in the very least don't fly often.
Yeah, a lot. See, it's like, you can tell, like, it's the same thing like in New York City, right? You can tell tourists apart from business people.
Now remember, when we say tourists, we're using the derogatory term because there are people who technically are tourists who are not, in fact, tourists.
Right. But you can tell, like a businessman, he goes whoosh right down the street, walks right into the subway, gets right on the subway car, gets right off, goes in the right direction all the time,
he dodges
around people.
And he just puts his bag up, sits down, he's asleep before you even see him there.
Right. But the tourists, like, they'll walk side by side, blocking the sidewalk. They'll walk down the street and then suddenly stop in their tracks with the person behind them bumping into them.
The worst are the people in D.C. on those long-ass escalators who will just stand right in the middle, elbows
you mean
out.
us?
You see, luckily there weren't many people around when we did that. And we did it knowing that it was a bad thing to do.
Yeah. But, it's in general, people who don't fly often get in the way of the people who do fly often. Just like people in New York City who aren't there often get in the way of me every day.
Yeah,
get out of my way.
The thing is, flying, if you look at it, it's not like it's a cryptic thing. I mean, if you don't know how the New York City subway works, or even if you've never taken like a New York Metro North kind of train before, no one's there to help you. You kind of have to figure it out. I mean, if you ask someone, they'll tell you like, oh, this is the train, blah, 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 and everyone's super nice. But if you just show up on a platform, you just show up on this platform and it says, this is the name of the platform, and trains are coming in both directions, and you don't know which one's what or whatever.
You know what I think, really the most efficient way to deal with the airplane boarding problem is that it's not even something people consider.
Have classes in high school to teach people how to get on a goddamn plane?
That would be, I guess, maybe help. But no, check this out. When you go to an airport, right, you go through security, and then the plane usually is already there at the gate, connected to the gate, right? And they make you wait there, like out, in the airport terminal for a while, right? And it's just pretty much, then they say, okay, now we're all going to get on the plane.
Well, a lot of that is FAA regulations. They're also cleaning the plane, usually getting it ready.
Right. But basically, they don't start boarding the plane till a few minutes, maybe 10 minutes at most before it's going to leave.
Usually the plane actually isn't ready until then.
Even so, a lot of times it's just sitting there. It looks pretty ready to me. You can sit in it while they're fueling it. You can sit in it while they're unloading.
No, you can't.
Why not?
There's rules against that.
I know there are rules against it, but why?
Actually, there's rules against that on a lot of buses, too. Anyone who's taken a long bus trip in America has learned that if you get on the wrong bus, they'll stop every time to get gas, wake everyone up, make them get off, and stand out in the cold while they drive the bus over and fill it up, drive it back, and let you back on.
Why can't you sit on it while it's fueling?
There's rules about that.
That's a rule that makes no sense to me.
Because it might blow up.
If it has gas in it anyway, it might blow up anyway. It's not gonna. There's no more risk of blowing up while fueling than while not.
I can say something, and this is definitely not a blanket. This is not a truth of the world, because there are people who have legitimate uses for these things, and there are circumstances where they're warranted. But multiple people have pointed out on Slashdot, and I've seen this sentiment elsewhere, that the best way to make airlines more efficient would be to ban anyone who shows up with wheelies on their baggage if the baggage is smaller than a gigantic bag.
I agree with that.
If the bag is smaller than your torso and it has wheels, just ban them from flying.
If your bag has wheels and you aren't checking it, then it shouldn't have wheels. If it has wheels, it's not a carry-on.
But I got to carry those lead bricks.
If you can't carry it, it's not a carry-on. And if you can carry it, it shouldn't have wheels because you can carry it.
Actually, though, I think pursuant to all that, if you think about it, another big problem, you see a lot of people have carry-on that, I actually check. I look at the dimensions. I make sure my carry-on is, within the legal, this is what you can bring.
I only ever carry on stuff I actually need on the plane.
Well, actually, before all these BS rules about can't have toothpaste or whatever, I would never check bags when I flew because I didn't need that much. I'd bring the 2 carry-ons I'm allowed. One was full of all my stuff, but it fit within the thing, and one was full of all my entertainment for the flight. And then I didn't have to deal with bag check or anything, in and out.
See, thing is, after, because I flew quite often when I was in college, back and forth from Rochester, I would always check exactly one bag and carry on my backpack. And that's what I would do, the same exact thing every time, right? And it was always cake, because I knew exactly what to do. I'd walk up, I would just dump my check bag, I would give them my ID and my ticket. They would go, yep. They would ask me all the questions. I would say yes, no, yes, no, right? I would just walk over to the security, go right through, get on the plane, get off the plane, go wait on the little conveyor belt. My bag would usually come out in 10 minutes, grab it and go. And that was it.
But then again, I flew a bunch of other airlines, and I never had a problem with JetBlue, but I've only flown them once, so I can't. But a lot of times, I'd show up, and the line to even check a bag would be 45 minutes long.
Sometimes there would be a line to check the bag, but you got to, you get there early enough.
And the worst thing,
that's only really on crazy holidays and really busy
even with
times.
JetBlue, when I flew to Arizona, right? It wasn't even a full flight. I had a full row to just kind of sprawl out and go on the way home and everything.
Mm-hmm.
But yet, when I got back to JFK, I had to stand there for an hour before my bag showed up.
Oh, that's a long time. Usually, I've never had to wait that long.
Well, I've had to wait that long 50% of the times I have flown JetBlue.
Oh well.
Yeah, but I find this article interesting because basically the gist of it is just that there are more efficient ways to do this, and airlines by and large don't. And the main reason they don't is because public perception is kind of wrong. And people would if you did it the intelligent way, people would complain. So they do it the way that's not intelligent, but looks intelligent to people who are dumb. And as a result, everyone's mildly angry. But I guess that's better than people being more angry, but actually getting on the plane.
Well, because if you change anything, people will be angry. If it had been a different way this whole time, then if you changed it to the way it is now, people would be angry. It has nothing to do with the way it actually is. It has to do with the fact that you're changing something. Therefore, people get upset. no matter what you change.
Of course, there's also the idea that if you just say, all right, go, and let everyone just get on the plane willy-nilly, it's still faster than the way they do it now. So
that's what I'm saying. They should just let everyone, as soon as the plane is ready, just let anyone get on the plane whenever they want, and then the plane takes off at the scheduled time. If you're not on the plane, fuck you.
Yeah, the problem with that, however, is that a lot of times people are making a connecting flight, and if the airline screws someone else over...
If your plane is delayed and you don't make the connecting flight, oh well, that's you bought a connecting flight. You knew that was a risk, and you just had to take the next plane.
Yeah, but
leaving.
the one time that happened to me, the flights were 2 hours apart, and yet the plane still fucked me.
Hey, that's a risk you take when connecting flights. Get a direct flight.
Yeah, sometimes it's not an option.
You pay more for a direct flight to reduce risk.
Actually, no, a lot of times direct flights are cheaper if you get them early enough. It was more that there were no direct flights.
Well, then what can you do?
Never fly to Detroit, ever.
All right. Can we move on?
I think we can. So, things of the day. I'm sure Scott, the other Scott, will be pleased with this. And I'm also pleased with this because I rather enjoyed it. And even if you do not know anything about the subject at hand, I recommend you take this quiz. Because by and large, the second hint is always hilarious.
I don't know much about the subject matter, but the quiz gives you so many blatant, obvious hints that it's really stupidly easy.
This is a pretty cool quiz, though. It is the booze test. And I'll warn you, I got almost a perfect score. I don't know what that says about me.
I don't think it's that. I mean, I would have, if I had taken the test,
remember,
I would have gotten close to a perfect score.
No, you wouldn't have, because you wouldn't have gotten them all on the first question. And you get 4 hints. And there's a list of answers. And you can either guess or get the next hint. Or guess or get the next hint.
So every time you get a hint, you just didn't get a perfect score.
Yeah, you keep going down.
All right.
So if you get a very high score on this, you're probably in the rim realm of alcohol usage. But I'll go through this a little bit.
So Thunderbird won.
This is a really fun, really well done quiz. Like here's an example. The first question, clue number 1. I am made with the flowers and leaves of a medicinal plant called wormwood. Now, anyone who drinks should know immediately what that is, or anyone who reads classic spy novels.
I do not know what alcohol is made of fermented wormwood. I'll be honest.
Now, you should, because it's pretty cool. Now, the next clue is a picture of absinthe.
Oh, I guess it's absinthe.
Yes. Now, that is only if you know that it is absinthe, but...
How would I tell it? What does it look like?
It's bright green with that special spoon. Anyone who's read anything about Bohemia or any of that stuff... If you've ever seen Moulin Rouge, you'll know.
A green liquid with a spoon might get me to guess absinthe. What's the next hint?
The next one is I'm illegal in the United States, which is not true anymore.
And then that would have tipped me off immediately because I knew that was an urban legend, and I would complain and I would get that.
Yep, and then I'm often
because it is multiple choice, right? I don't have to type in absinthe. Absinthe was one of the available choices.
Yes.
Yeah, so I would get that on the second or third one.
As the green fairy. Now, I think the best one is the kamikaze.
All right.
It's a drink, and the first hint is it's made of blah blah blah. The second hint is a picture of a kamikaze attack from World War II.
And it's multiple choice.
Yes.
Yeah, there's no way you can miss that.
Or
even if you knew nothing about alcohol, you couldn't miss that.
Gin. The first one is I'm flavored with juniper berries.
All right.
That's how I knew it, because I freaking love juniper berries.
Right.
Number 2 is a picture of one of those beef eaters. It's okay.
Talk about easy.
Yeah, but if anyone else gets a near perfect score, my hat is off to you.
Well, you just gave them a bunch of answers.
They will not get a perfect score if they do not actually know about alcohol.
All right, if you say so.
This is pretty fun, though. Check it out.
Okay. So I recently discovered this little open source project from Sun Microsystems, no less. Sun Microsystems, actually, Java's looking better and better every day. I'll talk about that sometime in the future, but I'll leave it at that for now. Sun is doing some good stuff. They're rebounding, at least in my eyes. Anyway, they have a project that's open source called Project Darkstar. Sounds pretty cool, huh?
Nah, well...
Well, what?
No, go on.
You don't think Darkstar is cool?
The name Darkstar is amazing.
All right, that's what I'm talking about. So this Project Darkstar, the goal of this project is basically, the thing I find most interesting about it is it doesn't seem to have any competition, right? Now, basically what it is it's a multiplayer game server engine. So it's not actually a game engine. It won't help you with, making your game or your 3Ds or anything like that. It helps you with making your game server. So if you want to make a game, most likely an MMO, that's sort of what it's designed for, where any game where there are lots of players sharing, the same space, the same resources, this Project Darkstar is a server framework that will allow you to easily develop and deploy a server that can handle that. And, it's still not, production worthy yet. They say as much. But in the future, their goal is to have it be very scalable. So, making an MMO game is very expensive. And one of the most expensive parts is making the server and getting all the servers up and whatnot. And if there is sort of this, one really good platform for developing those servers and handling them, then that could significantly decrease the costs of making and running MMOs, and maybe you could do away with, the monthly fees, or at least severely lower the fees to the players.
Or maybe someone awesome would take this sort of thing and make an MMO, because we've hinted at this a little bit in the forums.
That is not an RPG?
Debate. Or, no, maybe, see, the problem is that Mamorpaga, MMORPG, and MMO, and RPG have all kind of turned into very specific genres, even though originally, a role-playing game was a game where I play a role, and it's kind of gotten to the point where role-playing games have so little role-playing.
Yeah, you're heading to Tuesday territory.
Yes, but it's relevant. In science, in computing, one of the most important things is having a shared, useful nomenclature. This is why we had the debate over Pluto, and scientists said Pluto is not a planet. And anyone who disagreed with that statement, who is not a scientist, is a moron. Because basically, calling Pluto a planet makes the term planet useless. Because if Pluto is a planet, then there are hundreds of other things that are equally as useless as Pluto that also have to be called planets, or else we've just diluted the term planet to be useless to scientists.
Yeah, if we decide that, it's like a meter is exactly this long. If we decide, that's a meter too for sentimental reasons, well, now the term meter is useless in, scientific discussions.
I feel like the term MMO is useless now because most people, when MMO means a grind-based, massively multiplayer, stateful, avatared game.
Do you really think so? Because I think Mamorpaga is definitely, but I think MMO, I think...
In common parlance, most people say MMO to mean World of Warcraft.
That's true. I think you may be right there, but I also think that if someone were to specifically say MMO FPS or MMO RTS or MMO something else, or MMO puzzle, right, that people would, not associate it with Mamorpaga.
Well, I guess I feel that if we don't change course soon, that will no longer be true. And MMO will be a genre in and of itself.
I think
as opposed to what it should be, which is just a medium.
Yeah, pretty much.
It bothers me too that even MMORPG, the word RPG is useless to describe a game nowadays.
Well, I think that the term RPG, everything that is called an RPG has the common ancestor of Dungeons and Dragons and its ancestors.
Or Final Fantasy, all these sorts of things.
Right, but if you look, something like Final Fantasy 12, what is Final Fantasy 12? Well, it's a movie, and you push buttons to see the next part of the movie, and there's a little bit of exploring and such.
Yeah, we're not saying there's anything wrong with that, but
no.
How is that the same
as Burning Wheel?
Or as a role-playing game where you play a character and there's a lot of dialogue-based decision-making and reactions, and you play a role in a story.
Yeah, they're completely different things, yet you call them both RPGs. That's like, if I have a piece of paper and I have a bomb, like a bowling ball candle. I just thought of something weird, and then I call them both carrots.
It's like if I have an analogy and I
just
metaphor,
take as crazy as I possibly can go.
I have an analogy and a okay.
I don't know. I tried to make it silly. But anyway, this Project Darkstar seems like it's pretty cool, and I think it will encourage many people who, might otherwise veer away from developing MMO type games because of the difficulty and time and expense involved. Now, pretty much all you have to do is you get this Project Darkstar, you set your server up, right? And then you can develop the client end of your game in sort of any platform you choose. You could take the Unreal Engine, you could take the Source Engine, whatever. And you can make the client end. So people, who were formerly making like Half-Life mods or something, if they take this, it won't take much more work, or at least add the amount of work it would take otherwise, to make, say, an MMO source mod. So we're going to see a lot of, I think, quality MMO games coming out, maybe, if people recognize this project.
So I'll introduce what's about to happen, because we came up with something. We're gonna
try this out, do a little new thing.
We're gonna do this for 4 Mondays in a row, and then we'll probably take a break from it, go back to our usual fare, and then we'll try to come back to this in the future.
Yeah, hopefully we'll build up some other Monday fare in the
I got a couple.
You got some?
I got some. But anyway, the idea here is that for a long time, we've been avoiding certain topics, largely because either myself or Scott are an expert on it or know a lot about it, but the other of the two of us doesn't know so much about it.
We've also been sort of avoiding these topics because we sort of always try to veer away from going too deep, too technical, in fear of scaring away some people who might not want to be so technical. If I start talking about like the nitty gritty of like different memory management algorithms,
or if I start explaining exactly what the OID trees are in SNMP.
Yeah, if I start, explaining, why, the big O scheduler in the Linux kernel versus, the new schedulers, one is better than the other.
Or I start explaining the intricate details of why it sucks to synchronize time in a virtualized machine.
It's going to be a snooze fest.
Yes, but I think what we realize is if we kind of get away from this fear of going into topics where really only one of us has a lot to say and the other person is kind of the passive voice, and if we alternated between CS and IT effectively, we can probably get some really interesting shows out of this.
Or at least we think we will. It's worth a try, right? It's a free show we're making here. We can make whatever we want.
Plus, we're pushing 500 episodes here, so I think
we're running out of ideas.
Not terribly.
Not
we got plenty of Tuesdays.
We just came up with a bunch of new ideas, and this is one of them. So have it.
But I think also the fact that I think we can keep this interesting, because we're going to get into a lot of kind of real, like, awesome detail and deep depth, but at the same time,
or relatively deep depth. I'm not going to go too deep.
I think we can keep it interesting, especially because there'll always be one of the two of us who is not 100% together with all of this and might ask the questions that you at home are thinking, well, what about blah? Scott will say something about object-oriented something, and I'll go, waza?
All right. So today,
it's Scott's turn.
It's my turn. Basically, I realize I program for a living. I've been programming computers, technically speaking, since kindergarten when I was using Logo, right? Programming is pretty much...
I always turn the turtle into a helicopter.
Yeah, it's a good one. But programming computers is pretty much how I do. That's how I make monies. It's how I live. I went to school for it. I've been taking classes on it for even longer than, I technically went to school for it. I've been doing it for mad long. And I've done how many episodes of Geeknights? And we've actually only done one show on computer programming yet. And it was how to get into computer programming. I didn't even actually talk about programming itself or anything like that. So I figure what now I will do is I'm going to do a show on what is programming, because a lot of people are interested in it, but not many people really know. Even people who are programming don't really understand what they're doing, conceptually and for reals.
Yep. I mean, it's kind of, I'll say this, because I had a revelation early on in my IT career when I was trying to learn some programming language to do some crap for a class even. This was back when I was working at IBM and I was still going to RIT. And I was trying to program something. I'm making this program. It's getting bigger and bigger, and it's complicated, and it's frustrating, and I'm having trouble with it. And then I thought, and much like when I played Initial D, the arcade game, and I was trying to drift and do all this fancy stuff and learn all the craziness, and then I thought, and I was like, wait a minute. All I really want to do is get down the hill as fast as possible. Doesn't matter. I'm trying to do something. Why don't I just do it? Then I looked at my code. I said, why don't I just do it? And the end result is what I wanted, and I did it. And then I learned a lot more by thinking about what I wanted to get done as opposed to thinking about anything else.
Yep. All right, so before I start talking about what computer programming is, I gotta talk about what a computer is. We may have talked about this before, but it bears repeating, because if we did talk about it before, it was only once.
Also, I think Scott's going to talk about it in a way that will be very, very, I don't know,
I like how we're metaing this episode because it's such a test. All right, anyway. So, Rim, what do you think a computer is?
Well, a computer is a very complex machine that adds
Are you purposefully giving the wrong answer? Or do you know the right answer?
Well, let me get there. It's a very complex machine that the complexity exists solely to do a very simple thing over and over again, billions and billions of times.
No, not really.
Yeah, that simple thing is to add binary electrical signals to one another.
No, that's not a computer.
Okay, what's a computer?
Well, that could be a subset of computer. A computer is a device, any device, it could be mechanical, it could be electrical, it could be anything, into which you input some information somehow. The machine then processes that information and has a deterministic output based on that input. That is what a computer is.
Before you fancy pants think, wait, but what about a... No, you're wrong. Because if you made it, there was some initial input.
Yeah, pretty much.
And if there's no output, it effectively doesn't exist.
Yep. So yeah, you could have a computer that say, an abacus is not a computer. An abacus is not a computer because there is no processing. The abacus that you input, you move the little guys around, right? I don't really actually know how to use an abacus, I'm sorry.
An abacus is more like data storage for the brain that does the processing.
Yeah, it's like you move things around, but it doesn't actually process anything. There's no output. It's like you move a guy up and the rest of the guys are down. Well, that's it. It's the end of the road.
But
right?
What about, say, a clockwork mechanism to calculate where the planets will be in the sky?
That is indeed a computer. You would input the time and the date, right, of when you wanted to, what time and date you wanted the stars to look like, and then you would push a button or crank a lever or something, and it would move the planets and stars around, and it would show you the output where the planets and stars will be on the given date and time. An astrolabe, that is a computer, I guess. A pocket calculator, that's a computer. Right? Also,
my computer.
Oh, yeah, your computer. Your computer. It's a computer, right? All these things are computers, right? But many computers, right, are not programmable computers. For example, we just talked about a machine that would say, show you where these stars in the sky are, or a pocket calculator, right? Well, a pocket calculator, it does one thing. It calculates. 1 + 1 =, right? You can't change what it does. It is programmed already to do one thing and only one thing. It might do a complex thing like a pocket calculator or even a graphing calculator. Of course, many graphing calculators are programmable, so that's sort of a bad point. But a scientific calculator, not very programmable, really. No, not at all. So what is the difference between a programmable computer and a non-programmable computer? Well, let us consider, say, a light switch, right? You could almost say that a light switch combined with a light is a computer. You have input, switch up or down, and output, the processing is just, the thing is there's no processing in a light switch. It's just sort of direct, which is what sort of rules it out. But let's say you had two switches that controlled one light. That would be a computer. If you could be set to where, it's only on, the light only turns on if both switches are up, right? Okay, you hardwire that in. You connect electrical wires so that two switches are up, the light turns on. Any other configuration, the light is not on. That's a computer. There is a tiny amount of processing, the figuring out if both switches are up or not, and the output, the light turning on, right? But let's say you want to have a programmable light switch computer. Well, what you do is you add two more switches. And what happens is those two switches, basically, you could have it set where if the two additional switches are both up, that means the light will turn on if the original two switches are both up. And if the two additional switches are down, then the light will only turn on if the two additional switches are down. You have more inputs, additional inputs, and those additional inputs change the nature of the processing. The processing can be modified with more input. So you, instead of just having input that is then processed and outputted, you have input to modify the processing itself, and then the input, and then the output. So you can have one machine that can actually do different things because you can modify what it's doing. You could say have a pocket calculator, right? And then modify it so that the plus button actually is a minus button and the minus button's a plus button. You just changed the processing in the calculator, yet it's still a computer and it's still computing. But it's programmable because you can change what it does. Now, let me go a little deeper into how we do this.
Go deeper.
Go deeper, right? So you have your Pentium chips, right? Now, how does the Pentium chips work? Well, the Pentium chip understands instructions, right? Such as you could tell it to add, inside of the chip is a very small amount of memory in registers, but don't worry about it. I'm just going to say registers if that bothers you. It's just memory in the chip. You could tell it to say, take the data in register 1 and add it to register 2, right? You could tell it to erase register 2. You could tell it to look at the number in register 1, and that number is an address in the RAM. Go to the RAM and get the data at that address and put it in register 3. These are the kinds of instructions you can give to the chip. And the way you give it these instructions is binary. For example, the instruction to, move some data from one place to another, right, is actually, is like the move instruction is 001010101. I just made something up, but that binary string, that number, is the instruction. So you input that number, and the chip goes, aha, that number is the move instruction. And then you tell it the next number that comes in, and it goes, aha, that is what I am moving from. And then the next number that comes in, it goes, aha, that's where I'm moving to. And that's how these chips work, is you turn the chip over, and there's all these pins, right? Those pins take zeros and ones. That's all that can go on those pins, electricity or not electricity. And the instructions, they're all, if you have a 32-bit processor, these instructions are 32 bits long. You can have a lot of instructions because you can have 2 to the 32nd power different instructions you could have. They don't have that many, but you could. And these instructions are what we call the assembly language. That is what, people talk about assembly all the time and how it's so hard.
Like machine code.
Machine code, because it's the code of the machine. You're literally talking to the processor. It's as if the processor had 32 levers, and you were putting the levers up and down and then pushing a button to send that into the processor, and then changing all the levers and then pushing the button again. You're literally sending zeros and ones directly into the CPU, and because of if you understand how the CPU is made, there are books, and any CPU you get that's programmable has a giant book that tells you everything it can do and all the instructions and how it works and what's inside. All right, you are directly controlling the CPU with zeros and ones.
Now, obviously, writing any sort of imagine trying to write Half-Life 2 in assembly code. Try to break that game down to move this bit here, move this bit there, move this byte here.
Yeah, that's not going to be fun. That's pretty much the definition of pain. I mean, people have written some pretty impressive programs in assembly language. Usually, in the olden days before we had, more advanced technology, and also for very small devices where writing in assembly is pretty much necessary, because when you write in assembly language, the advantage is that you can optimize the code with your human brain to run very quickly on that machine and to take up very little memory. So your iPod, if someone writes the iPod operating system in assembly language, that operating system will end up being much smaller and much faster, making the iPod cheaper because you need less storage space to hold the operating system, so they can give you less flash memory, and make the device cheaper. And also, it'll be faster. The problem is it'll be much harder to make, so they'll have to pay the developers more money. And not many people know how to write assembly language anymore. It's a pretty rare skill, and every different kind of chip has a different language. So knowing how to write, assembly language for one chip doesn't mean you know how to do it for another. You usually have to read the book to learn the new chip and such. But anyway, so that is how programming chips works. You give instructions to the chips that tell them how to process, and then you give the input, which is more, following the instructions of how to process, and then the chips do the output, right? But assembly language is not fun. So we have programming languages, and this is where, even for me, a long time it was a complete mystery. It's sort of like, how do you get from programming language, like something like Visual Basic, right, down to the assembly language and the zeros and ones? It seems like there's this big fuzzy gap there. How did we get from here to there? How do you get from Windows popping up on the screen to assembly language? It's like, to the electricity zooming around on the motherboard.
Yep, especially as a kid when, I was writing stuff in QBasic, And I couldn't fathom writing something before I knew about a lot more computing. I couldn't fathom writing like Windows in that. And then I thought, well, how do I even load Windows? What's Windows running?
There's this big gap between the software world, right, which is all the instructions just in binary that you're going to send to the CPU. That's all software is. It's instructions to send the CPU, zeros and ones, conceptual zeros and ones. They don't have to be real zeros and ones. And the physical silicon in the chip that is going to take electricity into it and then change the way it processes and then take more electricity into it and then actually process. There's this big hole, and how does that hole get filled? Well, this is how that hole gets filled, right? You have a thing that is called a compiler. There's an alternative, which is an interpreter, but I'll explain that soon. What a compiler does is it basically takes it's a program itself, right? That is, you have a program already running on a CPU, right? And that program tells the CPU, right, to process input in a certain way. And what it does is it basically tells the CPU, take this input and then output another program. Think about that for a second. You program the CPU to output a program based on some input that is a program itself could understand. So a simple idea to try to get this across so you know what the hell I'm talking about. I could tell the CPU, okay, here's some instructions. Read from the memory in location number 1 in the RAM and then, make it equal to, number 32 and then output that back into the RAM. And then the next thing you should do, the next instruction that you should interpret, because when a computer is going, at least a modern PC, generally the way it works is there's a counter. And that counter is a place in the RAM. And it looks at that place in the RAM, and that is where the next instruction is. So basically, in the RAM, you would have lined up, say, starting with address number 1. It's like if a guy's I'm trying to explain this because it's really hard without a picture. Okay, so you're walking down the street, and every square on the sidewalk has a piece of paper on it, right? And that piece of paper says, do this. And then after you do that, you go to the next square on the sidewalk, and you pick up the piece of paper, and you do what it says, okay? So the RAM is the sidewalk, and what's in the RAM are those pieces of paper, and the CPU walks down the street doing what all the pieces of paper say. What if one of the pieces of paper said, skip over the next 2 pieces of paper? That happens. What if one of the pieces of paper said, erase the next piece of paper in front of you and write this on it instead? That is what we're talking about here, is a program. It tells the CPU to write a program for itself. And that is how programming languages work. You have something like C, right? You write in C, which is, if you go look at some C code online, you can find plenty of examples. If you just search for like hello world in C or something like that, you'll find plenty of examples of what C code looks like if you've never seen it. And there's a program called the C compiler. And the C compiler is a program, and the input to that program is C code. And the output of that program, what the CPU outputs is assembly language. It takes in, text, the letter A, the letter B, letter C in binary form. It processes them the way the compiler program has told the CPU to process. And the output of that program is a bunch of assembly language instructions. And if you were to feed those assembly language instructions back to the CPU, it would reprogram the CPU to now do what the program you wrote in C told it to do. So if you write hello world, the compiler, right, takes your hello world, the word hello world you typed into Notepad, it sends it to the CPU. The CPU then outputs a bunch of instructions, and then it walks down the street that it just wrote all the pieces of paper on the street. Then it went back to the beginning and starts doing what those pieces of paper it just wrote say. And it says, write the letter H, write the letter E. So it's like if you went to your refrigerator and you wrote down, get eggs, and then later you went to the refrigerator, you took the note off, and it said, get eggs, and you got the eggs. only it's a lot simpler to, the difference is that the human level of writing C code is much easier than writing the assembly code. So it's like it's translating for itself in a way, if that makes sense. And this is what computer programming is. Computer programming is writing instructions in sort of the higher level language, but also the lower level language, but in a language. And then if you're not writing in assembly language, another program that you could even program those programs. It gets that crazy.
So I guess at this point, where are you going to go with this the week after next? Where are you going to continue?
I'm going to go over probably a bunch of different programming languages, and talk about the differences between them and which ones are useful for what, because that's more of a real world problem. But yeah. One last thing I want to mention in this episode, though, is that, compiling is one way, but there's also interpreting. And the way interpreting works is basically when you compile a program, the way that works is you walk down and you give the program to the compiler, and it writes all the pieces of paper on the sidewalk, all of them. And then it goes back to the beginning, and then it does what all of them say. With an interpreter, it does it one at a time. So it rewrites one piece of paper, does what it says, then writes the next piece of paper and does what it says. And it does things one at a time as it goes through. And compiling and interpreting both have advantages and disadvantages and such. But they're the two different ways of sort of that programming languages do. But yeah, I wonder if that made sense. Tell me if that made sense, people.
Yeah, we'll find out.
We'll find out.
But,
did it make sense to you, Rim?
It made sense to me, but I'm an IT professional.
Yeah.
So we'll see. But speaking of IT professional, where I'm going to pick up next week is, a lot of people use the word IT, and a lot of people don't really know exactly what an IT department is. When I say a lot of people, I mean a lot of companies, too.
Yeah, mostly companies.
I'm pretty much going to explain in all the detail you'll ever want what IT actually is, what IT departments actually do. And I think it'll be pretty interesting, actually.
Yeah, a lot of people are like, oh, IT is just, the help desk, or IT is, those server admin guys.
IT is both more and less than all of that.
Yeah, pretty much. But yeah, programming, it's
What's for dinner?
Yeah, it's telling the CPU how to process.
This has been Geeknights with Rim and Scott. Special thanks to DJ Pretzel for the opening music.
Be sure to visit our website at www.frontrowcrew.com, where you'll find show notes, links, our awesome forum, a link to our Frapper map, and links to all the RSS feeds.
We say feeds plural because Geeknights airs 4 nights a week, covering 4 different brands of geekery. Mondays are science and technology. Tuesdays, we have video games, board games, and RPGs. Wednesdays are anime, manga, comic nights. And Thursdays are the catch-alls for various rants and tomfoolery.
You can send us feedback by email to geeknights@frontrowcrew.com. Or you can send audio feedback via Audio. Just click the link that says Send Me an Audio on the right side of our website.
If you like what you hear, you can catch the last 100 episodes in iTunes or in your favorite podcatcher. For the complete archives, visit the website, which has everything.
Geeknights is distributed under a Creative Commons Attribution Non-Commercial Share-alike 2.5 license. This means you can do whatever you want with it as long as you give us credit, don't make money, and share it in kind. Geeknights is recorded live with no studio and no audience. But unlike those other late shows, it's actually recorded at night.